Okay, hi everyone, and a warm welcome to the official YouTube channel of EduShort for your UGC NET Economics preparation. If you are someone who is following our lectures from quite a time, you will know that we are covering the most important topics, particularly in unit number 3, right? I started off with unit number 3, where you have statistics, econometrics, and a little bit of time series. And in the previous two lectures, we have covered the basics of statistics. We have solved past year questions on that. Then we have gone into econometrics, and we have also solved some past year questions, and we have touched upon some of the most important topics on that, right? So the previous two lectures, if you haven't watched those videos, then we will give the link in the description. And also you can check the detailed playlist out where you have, you know, unit wise topic, which is covered by all the faculty members, right? So you can check that out. So this is going to be our lecture number 3, where we will discuss some more important topics and some more important questions that has come in the previous years, and we will, discuss the topics along with that. So that is the agenda for this video. So let's start with December 2013, right? This question is saying, consider the following system of equations using standard notation. So this is a classic example of simultaneous equation model. So simultaneous equation model is there in your syllabus, where firstly we need to understand the concept of simultaneous equation model before solving these questions. So I have given you a short note from our paid course. So let's take a look at this and then we will solve this question accordingly, right? So what is simultaneous equation model? Simultaneous equation model, which is in short known as SEM, SEM, it consists of multiple interdependent equations. So if you see here in this particular equation, so you have three systems of equation, right? Here you have three systems of equation where there is bivariate causality. So bidirectional causality. So basically x causing y and y is again causing x. So if this kind of bidirectional causality exists, which is existing here, see here y depends on x, y1 depends on x. Again, x also depends on y. You can write x also in terms of y, right? Y is also depend on y itself. Y2 depends on y3, y1, and so on and so on. So x and y are interdependent in such a way they cause bidirectional causality. X can cause y can cause x. So separately estimating this system of equation using the ordinary least square method becomes impossible. If you have system simultaneous equation model, you cannot use OLS because that will give you biased and inconsistent estimate. That we will come in a while. So now just understand the structure of simultaneous equation model is such that multiple interdependent equations exist, right? Some variables are both dependent and independent variables. Dependent means they are the endogenous variable and independent means exogenous. So the variables can be both endogenous and exogenous. So one variable that is endogenous for one system of equation can be exogenous for other system of equation, right? So see here, for example, take the variable y1. What do you think? In the first equation, y1 is what? Endogenous or exogenous? Only if you look at the first equation, y1 is endogenous variable because it is determined from within the system. Right? It is determined from within the system. That is why it is an endogenous variable for the first equation. For the first equation. But if you look at the second equation, see y1 comes here. Right? Y1 comes here. So it basically means y1 then becomes exogenous variable. So an endogenous variable for one equation becomes an exogenous variable for the other equation. So it's very difficult to determine which is endogenous, which is exogenous. So you have to go by equations. Take a single equation and then analyze that what is endogenous, what is exogenous. That is the only way out. Right? So this is the basic structure of simultaneous equation. These models are caused when causality runs in both the directions, which I have told you between the variables. Right? So we have understood what is simultaneous system of equation, how it looks, and what is the context in which we use it. We use the equation, these kind of system of equations, when causality runs in both directions. Right? I hope this much is clear. Now I have given you an example to explain this concept. See, for example, two equation simultaneous equation model. So in economics context, demand and supply. This is one of the classic examples. See, here in the first equation, in the demand equation, QD is the endogenous variable. And what are the exogenous variables? P is what? Endogenous or exogenous? P is also endogenous variable because see, P is here also, P is here also. So in both the equations, they are present. So it will be also determined from the system. So QD is one of the endogenous variables, P is one of the endogenous variable, but Y is exclusive to this equation only, demand equation. Demand depends on your income. Y is income here. So demand depends on income. This will be an exogenous variable. And if you see from the second equation, which is the supply equation, QS is the endogenous variable occurring only once here. It will be determined from the system. P is also endogenous because it is present in both the equations. That will be determined from the system. And W is again exogenous variable because it will be given. It is given, it is exclusive to the supply equation. This is so first things first, whenever you are given with a simultaneous equation model, firstly identify which of the following are endogenous variables and which are exogenous variables. That is the first task. And as I have done here, see there are three endogenous variables and two exogenous variables, which endogenous are determined within the system and exogenous are determined from outside. So they are given basically, right? So this is the example. Now, as I have told you, you cannot apply OLS when simultaneous equation model is present. So you have to apply some other methods. What could be the alternatives in UGC NET? They have previously asked you this question. They can again ask you this question. What are the estimation methods in simultaneous equation model? The most common method will be two-stage least square method. Instead of using OLS, ordinary least square, you will use two-stage least square, where in the step one, what you do, predict the endogenous variables using exogenous variables, and in step two, use the predicted value in case of the endogenous frequency. So it needs separate class to explain the process, which is absolutely not essential for your exam. In your exam, the essential step is to understand that which of the methods are important. Only the names are important, not the method, because any which way they will give you MCQ questions. So they will not give you the method, but the names are important. And similarly, you have three-stage least square method. It is just an extension of two-stage least square accounting for cross-equational correlations. Then you have instrumental variable. Instrumental variable, again, a very important method in case of simultaneous equation model, uses instruments to obtain consistent estimators. Full information maximum likelihood estimates all the equations simultaneously, providing efficient estimates. So I have given you a single liner, description of this method for your convenience. But if you only remember the name, that will also be enough for your exam. And there is limited information maximum likelihood. Often it estimates one equation at a time, but accounts for the system-wide relationships, right? So if simultaneous equation model is present, is there, you cannot apply OLS. Either you will use two-stage least square or three-stage least square or instrumental variable or full information maximum likelihood or limited information maximum likelihood, right? This much I hope is done. Now, in case of simultaneous equation, one unique thing is that there is a problem of identification, right? So identification problem, if you want to understand, again, let's take a look at this demand and supply thing and try to understand why this identification problem arises. So suppose you have these two equations, demand and supply. Now, in these two equations, there are one exogenous variables each. See, here you have Y, one exogenous variable, here you have W, one. Only two exogenous variables are present. Now, suppose what I do is that I eliminate these two things, right? I eliminate these two things from the model. Suppose I don't know the income. I don't know W. What is W? I don't know. Wage. I hope this is wage. So wage and income, I don't know. I don't have the data about it. I just eliminate it. Or suppose you test hypothesis, you find that this alpha 2 and beta 2, the corresponding coefficients are, you know, statistically insignificant. So they are zero. They are not contributing anything. So you eliminate or drop them out. If this happens, can you tell me what will be the problem? See, look at this particular portion. What will be the problem? What will be the problem? If if you eliminate the exogenous variable, the problem is that here for notational simplification, we have written this QD and QS. For our notational simplification, for our convenience, we have written this suffix as QD and QS. But originally, you will have a data set. So can you specifically identify which one is the demand equation and which one is the supply equation? If you think of the data set that will be there, so you will have a data on price. One row, one column will be dedicated for price and one column will be dedicated for quantity. Now, with the data of quantity, can you specifically tell that it is the demand quantity demanded or it is the quantity supplied? The answer is no, you cannot do that. So if you have the price quantity data available to you, here you will have prices, here you will have quantity. You don't know it is quantity demanded or quantity supplied. So if this is the case, because you have only these two variables, quantity is one variable and price is another variable. So if in your model exogenous variables are not present or you are not taking them into account, then you specifically cannot identify which one is the demand equation, which one is the supply equation. And that is what is known as the identification problem. And it again, it arises due to that bidirectional causality that I have told you, that you don't know X is causing Y is causing X. So this bidirectional causality makes things a little messed up. So you cannot properly identify which equation are you talking about. Is this the demand equation or is this the supply equation? Which one is which equation? You don't know anything. So in order to handle this problem, this is the identification problem. And in order to handle this problem, you have two methods. One is the order condition, another is the rank condition. Now, rank condition, I have never seen, they have given you the rank condition. If you want, you can take a look at that. But in this video, I'll be touching upon the order condition, which is more important, which is more probable that in your exam it might come. But I'm not saying that just don't look at it. I'm not saying that. Please revise the rank condition also. We do this in our paid batch. So I don't have the scope to do this here because I have to touch upon multiple things. But if you want me, I can make a separate video for that. Right? So let's understand what is the identification problem. So before estimate, identification comes prior estimation. If you don't know which one is demand equation, which one is supply equation, you cannot estimate it. First, you have to identify what you are estimating, then you can estimate. So identify, this is also a question from UGC NET, that identification comes prior to estimation. So which one comes first? Identification comes first. Now see here, before estimating, we check whether the equation is exactly identified, over-identified, or under-identified. In case of exactly identified, if an equation you find that it is exactly identified, I will tell you how you will check that. If it is exactly identified, it can be estimated uniquely. Uniquely, you will get only one estimated value. Estimated value will be a unique value. That is why it will be exactly identified. In case of over-identified, it can be estimated using instrumental variable method and it will have more than one solutions. And in case of under-identified, you cannot estimate the model due to lack of information. So basically, if you have unidentified equation, you have to collect, you have to gather more information, you have to go into other processes in order to convert the model into these two things. In order to convert the equation into either exactly identified or over identified, only then you can estimate. Right now, identification has this order condition. This is the most important condition. And in many years they have given you questions. In December 2013, the question that we started off, we'll solve this after this discussion. There also the same concept will apply. See the order condition of identification. In order condition, you need three variables. Three variables you need to find out. First is what is K, second is what is M, and what is G. What is K? K is the total number of included variable in the model. Endogenous, it can be endogenous, it can be exogenous, because we properly don't know what is endogenous, what is exogenous. I'll talk about that, but it's included what is important here, included. And then M means the total number of variables in a particular equation or a particular model. It can be endogenous, it can be exogenous. And G is the total number of equations or the total number of endogenous variables in our model. Number of endogenous variables, that will be exactly the same as the number of equations that you have. So any which ways you can think of it. Now, what are the conditions? If you find that out, the values of all these three variables. Now, if you find K minus M is strictly less than G minus 1, then you will say the equation is under identified. If K minus M is exactly equals to G minus 1, you will say the equation is exact identified or just. This is exactly the same. Exact and just is same. And third point is, if K minus M is strictly greater than G minus 1, you will say the equation is over identified, right? So if you have this knowledge, then we can go back and solve the first question that we started off. See, I'll show you how you can do this thing. So it's very essential to understand this method because it might seem a little tricky. See here, in this first question, it says that you have this simultaneous system of equation. According to order condition, what will be the first equation? Whether the first equation will be unidentified, just identified, over-identified, or you cannot say anything, right? This is the question. Now, firstly, find out what will be K. K, as I've told you, is the total number of equations that are present in your model. Total number of, it can be exogenous, it can be endogenous. So, if you look at this carefully, how many endogenous variables are there? Endogenous variables are Y1, Y2, and Y3. that will be exactly equals to the total number of equations in your model. That is same. See, y1, y2, y3, these are the three endogenous variables. What are the exogenous variables? See, here you have x1, see, here you have x2, see, here you have x3. Anything else? Just check, there will be no other. So K is the total number of, in these three equations, all these three equations, what are the total number of endogenous and exogenous variables in your model? This will come out to be 6. So the value of K is 6. So first variable is done. Now the second variable is M. M means the total number of included variables in your model, in your particular equation. So see, first equation, we are here, want to find out the order condition of the first equation. So in the first equation, find out on the right hand side of the equality how many variables are there. They are the included variables. So this is one included variable. 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 So total 4 variables are there. They are the included. So y2 and y3 are included endogenous variables, and x1 and x1 included exogenous variables. This will come out to be 4. So the value of m is 4. The value of k is 6. And G is the total number of equation or the endogenous variable in your model, which is simply equals to G. So now if you find out K minus M, what will you get? 6 minus 4 is 2. And if you find out G minus 1, you will get 3 minus 1, that is 2. So what can you say about K minus M and G minus 1? Here you have 2, here you have 2. So they are exactly equal. Exactly equal. That is why this will be just identified or exactly identified. As I've told you, if you go back to the condition C, if K minus M is exactly equals to G minus 1, it is exact identified or just identified. I hope this process is clear. Now, as your homework, what I want you to do is to find out what will be the order, according to order condition, what will be this for equation 2 and equation 3. This is your homework. Please do this and let me know in the comment section what you get, right? So it will give you a good revision. I hope you got the process. And now I have another question for you. This is July 2016. I'll do this question, but for the first question, please do the homework and let me know in the comment section what you get so that I understand if you are getting the process, right? So the second question is saying, consider the following system of equation using standard notations. According to order condition, now the second equation will be what? So again, find out what is K, Y1, Y2, Y3. Endogenous variables are the same. Now, how many exogenous variables are there? X1, X2, X3. Anything else? No. So again, the same X1, X2, X3. So total 6, K is 6. Now, what is M? For the second equation, now we are doing it for the second equation. So how many variables are there? 1, 2, 3. So this is included endogenous variables and included exogenous variable is this. So it is 3. And G is total number of endogenous variable, which is 3 here. So K minus M is 6 minus 3, which is 3. G minus 1 is 3 minus 1, which is 2. So what you get is that K minus M is strictly greater than G minus 1. Right? K minus M, which is 3, is strictly greater than G minus 1, which is 2. So that is why it will be over identified. Right? This equation will be over identified. So I hope you got the concept. We have talked about what is simultaneous equation, how will you handle that, in what context simultaneous equation arises, and if it is present, how do you check the identification using the order condition, right? I hope this much is clear. Now, next question is on that only, December 2019 paper. For an exactly identified equation, the order condition that should be fulfilled in the equation is. So as I've told you, order condition for exact identified will be what? K minus M should be exactly equals to G minus 1. Now, which of the following satisfies that? See, the first option says exclude one less than the total number of endogenous variables in the model. Is this right? See this? This is absolutely right. See, exclude one. So we are subtracting 1 from G minus 1. G, as I've told you, total number of endogenous variables is exactly equals to the total number of equations that are present. So obviously G represents that. So exclude one less than the total number of endogenous variables. Total number of endogenous variable is G. You're excluding 1 from that. So this is absolutely right. Let's see the next options. Include 1 less than the total number of endogenous variables. That is not true because we are subtracting 1 here. Option C, include only one of the endogenous variables in the model. That is also not true. We have seen the process earlier. And option D, exclude 2 or more endogenous variables. That is also not true. So here the right answer will be option number A. For exactly identified equation, you have to exclude one less of the total number of endogenous variables in your model. Right? I hope this is clear. Now, this is about simultaneous equation model. The next question is from time series analysis. There are very few topics that is important for your UGC NET in time series. So this question is from June 2013. Let us see this. To test the stationarity of a time series in time series analysis, following test will be used. So remember one thing, whenever in your time series, unit root is present. If unit root, if you have unit root in your process, then the process will be non-stationary. Then the process will be non-stationary. And if unit root not present, then it will be stationary. This is one of the thumb rules in time series. Now, in order to check stationarity, what test will you use? You will use the unit root test. So from the name itself, you understand that it is related to stationarity. Unit root means non-stationary. Unit root present, it means the process is non-stationary. So here, if you want to test that if stationarity is present or not, you will use the unit root test. In unit root test, you have Dickey-Fuller test, you have augmented Dickey-Fuller test, you have KPSS test, various tests are there. But the group of tests, the name of the group of test is called the unit root test because we are trying to find out, we are testing the hypothesis that whether unit root is present in your model or not. Now see why rest of the things are not true. Random walk is a process. It's not a test. Random walk is also non-stationary, but it is not a formal process. Random walk is the name of the process. It's not a test. It's not a formal test. That is why this is not true. Now you have Cochrane-Orchard iterative process. This is used to find out autocorrelation. It is related to time series because in time series data autocorrelation might be present, very evident. But this is used to test if autocorrelation is present or not, not checking stationary. That is why it is not true. Similarly, Darwin-Watson is also used to check autocorrelation is present in your model or not. So these two tests are specific to autocorrelation, and this is not a formal test. Random walk is a non-stationary process. It's not a test. And unit root is the only test which test the stationarity of a time series. That is why A will be the right answer. And here I have given you the explanation also. See that stationarity means what? Stationarity means the time series is independent of time. Time series, the statistical properties of the time series is independent of time. So be it mean, be it variance, be it autocorrelation, anything that you consider, mean, variance, and autocorrelation, usually these three statistical properties, they will not vary with time. If this is true, then it is stationary. Now, see the unit root test like ADF, KPSS, PT is used to test the stationarity, testing whether a time series has a unit root, which implies non-stationarity. So as I've told you, random walk is not a formal test. Cochrane-Orchard and Darwin-Watson, they are used to check for autocorrelation and not stationary. So A will be the right answer for this question. Okay. Let's move to the second question, June 2015 time series question from time series, which is correct from a model to test the stationarity of a time series using Dickey-Fuller. Now, again, remember one thing for, as your thumb rule, that Dickey-Fuller, in case of Dickey-Fuller, you use autoregressive process of order 1. Always remember this, Dickey-Fuller, if you want to test stationarity using Dickey-Fuller test, you will always use the autoregressive process of order 1. But if you are applying the augmented Dickey-Fuller test, then you will use the autoregressive process, which will be some order greater than 1. Some order greater than 1. So basically for higher order autoregressive process, you use the augmented Dickey-Fuller test, and for order 1, you use the Dickey-Fuller test. So here they have talked about Dickey-Fuller, but augmented Dickey-Fuller, this question has also come in your exam. I think in recent year only, in 2024, I exactly don't remember the paper, but in recent year, they have asked you this question for higher order autoregressive processes. Which test will you use? You will use the augmented Dickey-Fuller. And this question is from 2015, where they have asked you about the Dickey-Fuller test. There you will have to use the autoregressive process of order 1. Now check which one is the autoregressive process of order 1. Simply option number D. So see this, where this delta yt means the difference, first difference, yt minus 1. Right? Yt minus 1 is equals to lambda yt minus 1 plus u. This is the process. This is the autoregressive process of order 1. Now, how do you check the test? How do you proceed with the test? I have given you here that you will set the null hypothesis as lambda equals to 0. So, in this equation, if lambda equals to 0, If this is true, then this portion is gone. So it will be what? Yt equals to yt minus 1 plus ut, which is a random walk process. That process I have told you. This is a random walk process which is always non-stationary. Random walk process. So random walk is a special case of autoregressive process of order 1. So if lambda is 0, then we will say unit root exists and the process is non-stationary. Specifically, it is a random walk process. Random walk process is always non-stationary. And alternatively, if lambda less than 0, if this is true, alternatives is accepted, then the process becomes stationary. This is how you check the process. Check using this test. And this formulation helps you to test whether the time series is stationary or not, right? So I hope this explanation is enough. And for so for augmented decay Fuller test, you will use the higher order auto regressive processes, and the test will remain the same. You'll again check the same thing. Hypothesis remains the same, right? So only the test statistic will change, and the data set that you are using that will change, right? So this is how you think of this. Now, this is a recent year question. I think it's 2019 paper. So it says, though two time series are individual, I'll check the year for this. I think there is some mistake. So see, though the two time series are individually non-stationary, their linear combination is stationary, then this will be an example of what? So this is the definition. This is the bookish definition of co-integration. Co-integration. Suppose you have two processes. XT is a time series process, which is stationary. Sorry, this is non-stationary. You start with two process XT. So basically unit root is present. This is I1, non-stationary, and YT is another process which is also having a unit root, which is also non. So I1 means non-stationary. Now, if you take a linear combination of these two things, linear combination, suppose lambda xt plus 1 minus lambda yt. If you take a linear combination like this, and if you see this linear combination follows a stationary process, you call this as the co-integration. This process is known as co-integration. So take two or more non-stationary, it may not be two, it can be more than two also. Take two or more non-stationary time series and take a linear combination of all of them. If you see that linear combination is following a stationary process, you will call this as the co-integration, right? This process is called co-integration. This gives you the long run equilibrium. In the long run, you see the linear combination becomes stationary. So that is why it is the long run equilibrium. The stationary means which is again not varying with time, so equilibrium situation. So here I have given you the explanation that non-stationary series mean their statistical properties will change over time. So xt and yt is initially non-stationary, so they are dependent on time, but the linear combination does not depend on time. See, if you regress one non-stationary series on another, the result is often spurious regression. Spurious means which is not correlated. Suppose the number of ice creams that you sell and the second ice cream that you sell obviously depends on time, obviously depends on season. And another is suppose the, what should I say, the number of shoes that you sell. If you take these two kind of these are completely uncorrelated. There is no correlation between the ice cream sell and the number of shoes that you are selling. But if you are mistakenly regress one thing upon the other, the process that you will get, the regression that you get will be spurious. Spurious means nonsense. You are not making sense, right? You can take the regression, you can do the regression, but it will not make any sense unless they are co-integrated, unless there is some sort of relation comes up, which will not come out. So co-integration means a linear combination of two or more non-stationary series becomes stationary, and this suggests a long-run equilibrium relationship between them, right? So this is a very, very important concept of co-integration. They have repeated this question few times. So please understand this concept well, right? And if you have any questions anywhere, you can let me know. Now, this next question is from June 2024. Okay, so see here, these are the four options that you have. Trend stationary, different stationary, weak stationary, fixed stationary. And the question was a stochastic process whose mean variance and auto covariance are constant over time. So only if the statistical properties are constant over time, which means that they are not varying with time, it will be weakly stationary. This is the definition of weak stationarity, that only the statistical properties are not changing over time. But what happens if the process itself is not changing over time? If the process itself is not changing over time, it will be strictly stationary. Strictly stationary means the process, the original process is not changing over time. But weakly stationary means only the statistical properties are not changing over time. The process, the original process might change. Now, what about trend stationary? Suppose in your data, trend is available. So the data is obviously non-stationary, trend is there. So if you remove the trend, suppose this capital T is representing this trend. So from the original process YT, if you remove this trend and then you see the process become stationary, then it is known as the trend stationary process, right? After elimination of trend, the remaining process becomes, if it becomes stationary. So suppose that the trend is like this, the initial time series process is like something like this, and you have clearly a trend, upward rising trend, and you eliminate that trend, then the process becomes this, then the process becomes something like this. So now the statistical properties are not varying with time, so it has become stationary. So this kind of stationarity is known as the trend stationarity. And then you have something called the difference stationarity. Suppose this original process yt is non-stationary. It has some unit root. It is non-stationary. So what do? You take the first difference. You take the first difference. That is the first lag value. Take the first lag process. And after taking this difference, you see that the process becomes stationary. If this is the case, this will be differentiation. So that is why all these things are not the answer here. They have only asked you about these properties. If the properties are constant over time, it will be simply definition of weak stationary. If the processes itself are remaining same, then it is strict stationary. Trend means if you eliminate the trend and then the process becomes stationary, it is trend stationary. And difference stationary means if you take any order, this may not be the first order. You can take second order difference, third order difference, and in some difference order, you will see that this process becomes stationary. This will be difference stationary, right? So C will be the right answer. And here you can see the explanation. Absolutely the same. The mean is constant over time, variance constant over time. Autocovariance between the two time periods may depend on the lag value. May depend. So if you are taking T and T plus H, these two time points, then the autocovariance that you are considering, that can depend on this lag value, which is H. Lag value. It can depend on the lag value, but it will never be depend upon the time. Time component should not be there. Lag values may be there. Then also it becomes a weakly stationary process, which is also known as second order stationary process, right? And then the final question, I guess, is from the Logit model. So Logit model and Probit model is again important topic. I have given you a single question here, but in the revision session, you will find the revision questions in the Telegram group that we will upload. There you will find more questions. I will give more questions there in order to give you a good practice, right? So prepare this Logit and Probit model very well, because one or two questions come from this particular topic. So see, in Logit model, as the odds ratio decreases from 1 to 0, the Logit becomes 1. So for that, you have to know what is the structure of Logit. According to the Logit model, Logit of T is simply the log of odds ratio. What is log of odds ratio? Log of odds ratio is simply this. This is P upon 1 minus P, where this P upon 1 minus P is known as the odds ratio. And logit is what? Logit is simply the log of this odds ratio. If you take the log of this odds ratio, it will give you the logit of. Now see, in the question, the odds ratio decreases from 1 to 0. So initially 1 upon 1, this was 1. Initially it was 1. If it is 1, so what was the value of logit P? Logit P was ln of simply 1. Instead of log odds ratio, put 1 here. Log 1 is 0. So initially it was 0. Now it has gone to 0. Now this becomes from 1, it becomes 0. So what will be the logit P? It will be simply log of 0. What will be log of 0? Log of 0 goes to minus infinity. This I hope you know. From the diagram also you can refer to this. Log 0 does not have any exact value. It tends to minus infinity. So what will happen to the logit? Logit will also go to minus infinity. So logit becomes what? Logit will become negative. Logit goes to minus infinity, which means logit becomes negative. It will not be equals to 0. It will not be positive. It will not be fraction. So A will be the right answer for this question. So here, see, I have given you the same, thing. You can take a look at this, or I'll share this PPT in your Telegram group. If you haven't joined the Telegram group, then please do it, because there we share revision questions also, and this lecture notes also, and some useful notes also. So if you want to get that, please join the Telegram group. And if you like this video, then give me a thumbs up and do subscribe to this channel of EduShort. And I hope to see you in the next video. And in this lecture, if you have any questions, or in any past year questions, if you have any questions, if you are stuck with any question, you can write me down below in the comment section and I'll help you out, right? So all the very best for your exam and stay tuned for the next video. Thank you.